Hello friends, so this is our problem uh, of problem solving day 3 for Leetcode challenge. So let's look at today's problem. Okay, so given an unordered tree consisting of main vertices numbered 0 to n minus 1, which has some apples in their vertices. You spend 1 second to walk over one edge of the tree. Return the minimum time in seconds we have to spend to collect all apples in the tree, starting at vertex 0 and coming back to this vertex. Okay, so let's take an example and understand the question. Okay, yeah. So this is our tree and this is edge. So what does the edges actually mean? So 0 to 1 means actually from 0 vertex there is an edge to 1 vertex. 0 to means from 0 vertex there is an edge to 2 vertex, and as it is an undirected graph, so 0 to 1 there is an edge, so 1 to 0 there is also an edge. Okay, so if there is a path to 0 to 1, there is another path from 1 to 0 also, right? So 1 to 4 means 1 to 4 there is a path, so again 1 to 5 there is a path, right? 2 to 3 there is a path, and 2 to 6 there is a path. Okay, so vertex 0 no apple, vertex 1 no apple, vertex 3 an apple here, vertex 4 no apple, vertex 5 an apple, vertex 6 an apple here, vertex 7 no apple, 0 1 2 3 4 5 6, vertex 7 also there is no vertex 7, vertex 6. Okay, so vertex 0 and apple, no apple, vertex 1 no apple, vertex 2. Okay, so it's actually vertex 2. I made a mistake. Vertex 0, vertex 1, vertex 2, vertex 3, vertex 4, vertex 5, vertex 6. So these are representing where the apple is. Okay, so in 2 there is an apple, in 4 there is an apple, and 5 there is an apple. So suppose you start from here, you go here, so you get an apple, right? You have to go back to the vertex, root vertex also, right? You don't have to just go here to here, you have to back to the original position. So each of time 1 second. Okay, so to reach 0 to 2 you have 1 second, from 2 to 0 you have also 1 second, so you spend 2 second time already. Now 0 to 1 1 second, 1 to 4 1 second, another, you got an apple at 4, so 0 to 1 1 to 4, so you got an apple. Similarly 4 to 1 1 to 5. Okay, then 5 to 1 1 to 0, so this is the path from 0 to 4 and 5, and again back to 0 to collect the apples. I am telling you once again, I came here, from here there is no apple, I check here there is an apple, so the total cost from total time from here to here is 2 seconds. Okay, then I came back here and I start searching for second child. Here is an apple also, so it takes from here to here, it takes 1, and from coming back from here to here, it takes also 1, so plus this one plus this one 2, and plus, so plus this, okay, plus this coming back to 0 also, so 1 2 3 4 5 6, 1 2 2 second, 3 4 3 4 to reach here, then again coming back to this node, which is 1, which is 1, right? Coming back to this node, which is 1, so that needs another 1 second, plus 1 to 0. Oh, okay, so let me erase this thing. So from 0 to 1, 1 second, 1 to 4, 1 second, 4 to 1, 1 second, 1 to 5, 1 second, 5 to 1, 1 second, 1 to 0, 1 second. So total 6 seconds for getting these two apples, and 2 seconds for this apple. So I need total 6 plus 2, 8 seconds to collect all the apples. Okay, I am telling you 1 second the thing. Okay, nothing to worry. So here is 0, 1, 2, 3, 4, 5, 6. Here is an apple, here is an apple, here is an apple. I do not just need to come here and collect apple, I have to also get back to the original position. Okay, so suppose here is your home, here is a tree. Okay, so you collect apple, that is okay. You have to get back to your home, right? To eat that, you will eat it in your home. So you have to get back to the home also. So home is here. So from 0 to 2 it means what's 1 second. 2 to 0, after collecting apple, it means also 1 second. So one apple is collected. Now here 3, 4, 0 to 1, 1 second, 1 to 3, another 1 second. Now come 3 to 1, come back to 1, right? So 3 to 1, another 1 second. Then 1 to 4, another 1 second. Then 4 to 1, coming back to 1. Here I come, here I come, I go back here, I come here. Now I go back here. Now another 4, 1 to 0, so plus 1. So in total 1, 2, 3, 4, 5, 6, and here 2. So in total I need 6 second time for collecting all my apples. So this is my question. So I will do it by depth first search. So for each vertex I will do a depth first search. That is, I will search from actually how it works. It will work like this. That is, I am going to show how it will work. 0, 1, 2, 3, 4. Yeah, so I start from 0, come to 1. I am doing depth first search. From 1 I will come to its next child, 3. Then here is no other child. I will come back here, and if we had an apple in my last visited vertex, I will update my answer as this 1 plus 1. Again it will look for this child, and there is no other child in 4, so it will come back to 1. So my call is coming back to 1. I mean it's my last visited child. If it has an apple, I will update my answer again as plus 2, this one plus this one. So from here I am getting an apple, right, under this subtree, you can say. So if I am getting an apple in this subtree or in this vertex, so here in this case in the subtree I am getting an apple, not in this vertex particularly. So I will update my answer to 1 plus 1 plus the subtree result. Okay, so subtree result plus 1. Then I will do same for 2. So it will call for 2, and again for 5 there is no other child. It will come back to 2 and add 2 at the updated result plus 2. Then again it will go to 6, another no child, it will come back to 2. So 6. Okay, so why it will update its result? There is no apple in 5 and 6, right? So I made a mistake. Yeah. So after that it will come to 2. Then it will call 5. 5 has no child. So the call coming back to it came back to 2. Then after that here is no apple, right? Here is no apple, so no result will be added. Now it will check for 6, there is no child, it will come back. So is 6 has an apple? No, no apple. So 2 will come back to 0. So in 2 there is no, so up to 2, so this subtree actually doesn't have any apple. I mean under 2, not including 2, under 2 there is no subtree containing an apple, but 2 has an apple. As in our question, 2 has an apple, right? So in our question 3, 4 has an apple and 2 has an apple. So either my subtree will contain an apple or my this vertex will contain an apple. So in this case my vertex is containing an apple. So after coming back from 6, it will come back from 2 and reaches 0. So 0 will check my last visited vertex, which is 2. So is 2 has an apple? Yes. So I will update my result now. Okay. So that is why it's working. So so we are going like in depth first. So we are going like in depth first, right? We are going like this, then this, then this. We are not going like this childs, then again another level childs. We are not going like this. We are going like depth manner. So that is when we need depth first search. Okay, so that's it. So now let's code. Code is very easy. We just create an array list. Array of name graph. So I have how many vertices? 8 vertices, right? So I have to create an array list of that size. So graph I is equal to new array list. Okay. Yeah. Okay, then what will I do? I will traverse the edge part. I'm traversing the edge part. Okay. So edge has I'm traversing the edge part. So edge part has 2 vertices, right? Suppose this is val. Traversing the edge part. Okay, so what I will do? So in graph, I will set yeah. So in graph val 0, it will add val 1, and in graph val 1, it will add val 0. I will tell you what I am doing. Now I will call DFS. So my previous vertex, current vertex as my 0, and the graph and this one has apple. Okay. So it will give me the answer. So I will return this. Let me create this function, public int dfs int previous vertex, int current vertex, and this graph. And this thing. Has apple. Okay. So here what we'll do, just create a loop for each each vertex of graph graph suppose graph current. So if x is not equal to my previous, what will I do? Let's store this an answer. Store this in my answer. Okay. Call a function. So previous as my current as my x, and this thing, and the has apple. So after them, I'm checking if my answer is greater than 0 or my has apple of last visited vertex is true or not, or I can say directly by it. If it is true, then update my result. Okay. So here is a result thing. Original answer. So I will update this by this answer plus 2. Okay, and I will return an original answer. Now let's run this. I think it's okay. Let's run this. It has an error. Yeah. Why? Edges, okay. It's edges. Okay, so we have to do it here. We are creating array, so it will be like this. Okay. So let's run this. So it's accepted. Now let's submit it. Then I will try run the code. Okay, so it's working. So let me show you what we have done. So what it does actually. So see. So let me just take a screenshot. So see what we are doing. We are creating a graph, like, right? Graph which is an array list of which is an array of array list, right? So array of array list, array of array list. So here is an array. Okay, so I'm writing, instead of writing like this array, I'm writing like vertically. Okay, so it's a, so this is like the array. 0 1 2 3 4 5 6. So this is actually the graph array of array list, where each element contains an array list of collection of vertices it is connected to. That means that suppose 0 is connected to 1, so I first create an array of array list like this. I put 1 in front of 0 and 0 in front of 1. That means one vertex is connected to 0 and 0 vertex is connected to 1. So it is an array list. Here is an array list in my 0th index. Okay. Now 0 element is also connected to 2. So we'll place here 2, and in place of 2 I will write here 0. 1 is connected to 4. So place 4 here and place 1 here. 1 is connected to 5. Place 5 here. Place 1 here. 2 is connected to 3. Place 3 here. Place 2 here. 2 is connected to 6. Place 6 here. Place 2 here. Okay. So this is the thing that we have done. Okay. This is the thing we have done. So graph is an array of array list. So the actual thing is like this. It will contain like this. Okay. 0 3 6, then 2, then 1, then 1, then 2. So this is actually the graph represents. Okay, so that is why what I have done using this part. I'm showing you. I'll show you everything. Right? That we have done. See here. That is what you have done. I have put at index value of 0. At index value of 0. So values are these elements. This array. So value is an array which are there. 1 5 2 3 2 6. These are the vals. So vals 0. That means 0 here. So for the first one, it's 0. So in 0th position, I will put 1 in the 0th array list. So I put 1 here, right? I put 1 here, right? And in 1th position, put 0. Again the loop goes. In 0th position, put 2. In 0th position, put 2. The array list at the 0th position. And in 2nd position, put 0, right here. So that is how I have created this graph. Okay. So this graph actually is very for simplicity. Now I call DFS. So suppose this is my tree. Okay. So this is very big. Let me. So this is my graph. Okay. Oh, sorry. So these are the important things. Okay, that you have to keep in mind. This is the first thing. This is the second thing. Let me erase this part. Okay. Now, suppose this is my vertex. 0. This is 1. This is 2, 3, 4, 5, 6. So here the DFS is called, right? So now in graph of current, my current is now 0. So graph of current. So this is the thing. So what I will do, is graph of current. So graph of 0. Okay, so from graph of 0, so what is graph of 0? 1 2, right? So what it represents, so what does graph 0 represents? Graph 0 represents the children set or the array list containing the childrens of 0th vertex. Graph 0 represents the childrens of 0th vertex, or we can say graph I will represent the childrens of ith vertex, right? So it represents this thing. So here is a here is my 1 2, and x is my first thing 1. So for 1 this part goes. So for 1, so for 1 I call DFS again with current value as my with so this first argument is my previous, and second argument is my current. So now for this part the current is actually the previous is actually 0, which is my current here in this function. That is why I am writing current here, and x that is 1 is my current. So I am placing x here in the second position because this is my actually current element. So for 1 it will be called as, for 1 it is previous is 0 and current is 1, so it called it GFS. So again the DFS is called. So for that the previous becomes 0, current becomes 1. Okay, so now graph of 1, so this line is again called graph current. Current is 1, so graph current is this part. So then the loop goes for is 5 is there, 1 is connected to 3 and 4, right? I had a mistake. I must have had a mistake. Yeah, I think I made a mistake. 1 is connected to 4, right? Yeah, 1 is connected to 4, 1 is connected to 5 also. Okay, so yeah, so the graph will be like not like this. The graph will be like, so 0 is connected to 1 and 2, 1 is connected to 4 and 5, and 2 is connected to 3 and 6. So the graph is like this. Okay, so 0 1 is called, so for 1 it's the current and previous is 0. So now graph current is called, so current is 1, so graph current is 0 4 5 0 4 5 0 4 5. But I am doing the DFS again for where x not equal to previous. That is, suppose I took x as 0, so 0 is my previous, right? So I will not take 0, I will take 4 and 5. So for 4 the call is on, and I call 4. Now here 4 is my current, previous is 1. Now for 4, when the DFS is called, actually there is the loop runs, but it has only one connected vertex, which is 1, which is also its previous. So it will return actually 0. There is a return original answer which is 0. So it will return 0. So after returning 0, now for 1 what we will do, so here for 1 my answer becomes 0. So my answer greater than 0 is false, but has appel dot get x is right. X is my last visited vertex for 1, which is 4. 4 has an appel, right? 4 has an appel, that's why in place of 4 there is a true. So if 4 has an appel, I will update my answer to, so for 1 to 4, if I have to collect an apple from 1 to 4, I will go like this and come like this. So there is 2-second time needed from 1 to 4 to collect an apple and going back to 1 again. So that is why I am adding 2, and I will return 2 here. So right, so that is the thing. So for this part also it's go like this, go like this. So okay, so for 5 also it go like, it returns 0, and after that here is an apple, this line is executed, so I return again 2. So then from here I got 4, and from here I got only 2. So that is how I am getting the answer. What is my answer in that case? Let's see. What was my answer? 8, right? So yeah, from here I got 2, from here I got 2, from here, from 1, right? From 1. So let me erase these things. From 1, so from 4 it was calculated 2, from 5 it was calculated 2, and we got 4 in 1. I got 4 in this part. Okay, so now now when 1 come back to 0, now suppose this is the code for 0, so this line is executed. My answer is greater than 0. My answer is 4 now, for 1, sorry, for 0. For suppose this is the code for 0, so my answer is, so this line is executed, my answer is now 4, right? So this is true. Now I will add 2 here. Why? Because for 1 to 0 I came to 1 by once taking 1 second time. I am going to again 0 by, I will take 1 second time again. So that is why I am adding 2 for each case. From whenever I come from B, I must have gone to B once, right? If I go from B to A, that is B is a child of A. If I go from B to A, it must have to be happen that somehow, somewhere, somewhen I have came to B from A, right? So I came from A to B once, and after that, that is why so what I am telling is, to come from B to A, I have to reach B first, right? I am at A. If I don't reach B, I can't reach B to A. I have to reach B first, then I will do the work, then after that I will go from B to A. So I have done the thing from A to B, and after that, so I will calculate this part from A to B plus B to A also by adding 2. So for this total case, the thing is 6, and for this total case the thing is 2, that is as 2 has an apple. So 6 plus 2, 8 is my answer. Okay, so that is how it's going actually. If you try run this, you will understand it very clearly. So this is the thing. So I hope you like the video, and let's see you in the next video then.